Hey everyone, here's my Teach the Doc for Chapter 7. So for this first one, we had FCl. This is a polar bond. The F has the partial negative charge, and the Cl has the partial positive. Just looking at the periodic table, and the electronegativity version, F is more negative than the Cl, so the Cl is drawn to it. This one is non-polar because the electronegativity is equal per the chart. This one is polar, with the bromine being the more negative one, so it carries a partial negative, and then the hydrogen carries a possible or partial positive. BH is non-polar, that electronegativity difference is 0.1. And then this one is polar, the Cl is the partial negative, and the sulfur is the partial positive. So that electronegativity difference there is 0.5. Drawing the Lewis structure, so did the correct bond angles here. This one actually needs to be straight. I can fix that right now, but when I was just kind of doodling, that's what I came up with. So we have O. And we'll just do this. And that's actually non-polar because the dipoles cancel each other out, which confused me for a minute, but I think I finally got it. And then H2O is polar. The oxygen carries electronegativity of 3.5. The hydrogen is 2.1. The difference is 1.4, which makes it polar. The polar charge is going up to the oxygen because it's the more electronegative one. So that carries the partial negative charge up there with the oxygen, and then the hydrogens are the partial positive. The example of a polar linear molecule that I chose was hydrochloride. So the hydrogen bonds to chloride. We got all of our lone pairs there. The chloride has the partial negative charge because the chloride has electronegativity of 3, and the hydrogen has 2.1. It's different from the CO2 because the dipoles on the CO2 cancel each other out, making it nonpolar, but we don't have that example here, so this one is polar. Going over to the chart here, so just going down the line, it was 1 through 7 for the number of valence electrons in each group, just using the group, 1 through 8, using the group number to determine that. And then so going down the line, lithium has 1 valence electron. We've got 2, 3, 4, 5, 6, 7, and then 8 as our happy neon. Total valence electrons, just did this by drawing the Lewis dot structures. So we have 6 valence electrons, 7, 7, making a total of 20. Carbon, helium, nitrogen got 10, and then SO42 minus. So we add 2 extra electrons here to get that -2 charge, so it's 32 total. The formal charge on an atom is equal to the number of valence shell electrons minus the number of lone pair electrons plus half the number of bonding electrons. So the formal charge on each atom for CO, so the carbon is -1 because we have the 4 valence shell electrons minus the lone pairs minus the bonding electrons, and that is also how we found the oxygen. Formal charge is +1, so kind of just doing the same thing. It has 3 bonding electrons though. This chart, let's see, so H2O has 2 lone pairs in the central atom, as seen here, and it's a bent or angular shape. This next one has no lone pairs, so it's trigonal planar. This next one has 2 lone pairs, and then so it's square planar. Then we have no lone pairs again, with our 5 groups, so it's trigonal bipyramid, and then no lone pairs again, so we have 6 groups of electrons here, or pairings, which makes it octahedral. So we could kind of use this table here to help out with the next section when we get more into the molecular geometry again. I had to kind of sketch out my Lewis dot structures on the side here just to kind of make it make sense in my head, but that's kind of how I got my reasoning here. So with CO2, there are two bonding groups of electrons. There are no lone pairs on that carbon, which is going to give it a linear shape. And again, for some reason I drew it bent in there, but it is supposed to be linear. So for the 3 electron groups, we have BCl3 as our example, which is going to be trigonal planar because there are 3 bonding groups of electrons, no lone pairs. The 4th one is going to be tetrahedral because it also has no lone pairs, but then 4 bonding groups of electrons seen there. And then H2O has 2 bonding groups of electrons, but 2 lone pairs on that oxygen guy there. So there they are. So it's going to be a bent tetrahedral shape. For SF4, it's going to be 4 bonding groups of electrons, 1 low pair on that poor sulfur there. It's going to be a seesaw trigonal bipyramidal shape. And then for the last one, there are 4 groups of bonding electrons and then 2 lone pairs. So it's going to be square planar. And just kind of showing where I got all my information from. I used Dr. V's PowerPoint here and kind of just went through and used process of elimination about what all the things could be. I did my Lewis dot structures on the side too because I think that really helped me like make sense of the lone pairs and everything. So here we are, and that is my Teach the Doc. Thank you.